Hey, welcome back. In this video, I'm going to introduce selection sort, our next sorting algorithm. So I wrote down that it's similar to bubble sort, but instead of first placing the large values into sorted position at the end of the array, we place small values into sorted position one at a time. So we're building the array, we're still moving from the beginning to the end, but the actual sorted data is accumulating at the beginning. So let me give you an example of how it works. We go through. Here's a single pass. So we have this array. We start at the beginning, and what we're going to do is go all the way through looking for the minimum value, and then we're going to put that at the front. So for example, we start with 5 and 3. Which one is the smallest? Well, 3. So 3 is going to be our minimum for now, which is what the green means. But then we now compare it to 4. Which one is the minimum? It's still 3. So now we compare it to 1. Which one is the minimum? Well, now it's 1. So you can see 1 is green now. So that's our new min. Now we compare 1 and 2. Which one is the minimum? 1 is. So what we do, now that we've hit the end, is we swap. We take whatever the minimum element was with whatever we started with. And so now we've put the smallest item in the array at the beginning, compared to bubble sort, where we go through and we swap potentially to push the largest element, the greatest value, to the very end. Selection sort builds it the other way. We find the minimum, swap at the end, and put it at the beginning. So let's walk through on Visual Go, however you say this, visual algorithms. And I have a small data set here. If we step through, we start at the very beginning. This is our first position, and we set a minimum value to be 19. So that's the smallest value we've seen so far. Next, we compare it to the value next to it, 44. Is there a new minimum? Nope, 19 is still our minimum. Now we move on and compare it to 38. Is there a new minimum? No, 19 is still the smallest. Now we get to 5, and we compare them. 5 is now the new minimum. So that's our new min. We move on, we compare it to 47. Nope, 5 is still smaller. Same thing with 15. We've now hit the end. We know that the smallest element in there is 5. So what we do, we started here. So we now swap the smallest element. As you can see, we have the two things selected, the beginning where we started and the smallest element, and we swap them. And now we start over, but this time we start from 44. So I think that's just showing us that this part is now sorted. We don't have to care about it. So we move on. 44, we compare, okay, the minimum now is 38. Now the minimum is going to be 19. Now it's still 19. Now it's 15. So the new min is 15. So we swap it with 44. There we go. Okay, so now the first two things are sorted. Now we move on. 38 and 19, 19 is the min. 19 and 47, 19 is still smallest, 19 is still smallest. We swap 19 and 38. All right, so hopefully you get the idea from here. We keep going, find a min in that place. In that example, the min was what we started with, 38. Now we just have to swap the last two, and we're done. So that's selection sort. We are going through and selecting the smallest element, the minimum, and then putting it at the beginning. Oh, and actually this hasn't finished officially. There we go. Now it's done. We have a sorted array. So as far as the code for selection sort, it's actually not that bad. We reuse the swap code. So if you made a function for swapping in the last video in bubble sort, or you want to use the one that I made, then we don't have to worry about the swap logic. So let's walk through some of the pseudocode. Okay, so the first thing you want to do is make a variable to store the minimum value. And at the beginning, you can set that equal to just the first item. You have to start somewhere. So the first thing in the array is our smallest value. So that's the only thing we've seen. Then what we do is we go through and we compare it to the next item. If that next item is smaller, now we update the value of the minimum variable to be that next item. And if it's not smaller, we keep going. And if we at any point find a new smaller value, we save that to the minimum. Now, what are we actually saving? Well, we're not actually saving the value itself. What we're going to save is the index of where that value is found. So then we can swap. So we don't care if the value is 20. We want to know where it is, index of 3. So then we can swap index of 0 and index of 3 after our first pass. So that's what we have here. If a smaller number is found, designate that smaller number to be the new minimum and continue until the end of the array. If the minimum is not the value, the index, which is why I put that there, you initially began with, then swap the two. Otherwise, If they are the same, it means that we happen to have an array where the first element was the smallest element. We just got lucky. Or maybe it's already sorted, which that's not going to be good for selection sort. And then we just repeat this process. Of course, next time we know that the first item is already sorted, so we don't need to loop over every single item. What we want to do actually is start from the next item afterwards and find the new minimum. Otherwise, if we kept looking at the whole array every time, we would always find the same minimum, right? If we just started from here again, this is our min, and we compare, our min is still going to be 1. And if we started again, it's always going to be 1. So what we need to do is then look at this area and find the min, and then look at this, and so on. So we want to shrink the scope, our window of what we're comparing as we loop through. Okay, so give this a shot if you'd like to. It's a relatively short one to implement as well. Really, it's just a loop plus another loop and a single conditional, and then at the end a swap. So give it a shot, but also don't feel bad. I don't want to make it sound so easy. It still conceptually can be tricky to get these to work. So in the next video, I will implement it, and we'll see how it goes.